Alrighty, easy. Find all k distant indices in an array. You're given a zero-index integer array nums and two integers key and k. A k distant index is an index I of nums for which there exists at least one index j such that the distance between I and j is less than or equal to k and nums at j equals key. I see. So k distance, so it has to be, I'm trying to find a key value and it has to be within k of it. Return a list of all k distant indices sorted in increasing order. K distant indices. Okay, so here key is 9, so 9 is here and here. And k is 1, so the indices that are at most 1 away from where 9 is 1, 2, 3, and 4, 5, 6. So that's how you get it. Here key is 2. Everything's 2, so all the indices should work. So 0 through 4. Okay. Guess the thing that comes to mind is whether or not I need to actually sort at some point, because sorting would take O of n log n for time complexity. But if I don't need to sort, then I can make it O of n. So can I make it O of n speed? Can I make it O of n speed? I think if I go through if I do one pass through the array where I determine where the keys are, maybe have an array of indices where the keys are. Can I do it in just one pass then? Let's see. Okay, I think I might be able to do it in one pass. Although two passes would be simpler to logically go through. But let's say I have let's say I have two indices. One is where I'm looking at. Okay, let's say for every index in range of n, where n is the length of nums, I'll go and say, actually, say that, okay, I'll say answers, I want to say last index is maybe -1. I have a feeling that I want something that keeps track of the last thing that I stored into the answer array. Currently answer array is empty, but I'm going to say that maybe empty means it's -1 is the last index. So for every index in range n, if the index, let's say, if the value, if the nums at this index equals the key, then I want to go through all indices that are at least at most k away, starting with index minus k all the way up to index plus k. So if index is like 5 and k is 2, then I want to go from 3 to 7. So I want to say for for everything, for every good index in range of last index to in range of the maximum between last index and current index minus k, whichever's bigger, and index plus k. Okay, so last index is 0. Last index should be 0. So I want to say last index is the last valid thing that I already stored, not inclusive. So 0 hasn't been stored yet. And so the first time this does it, max of 0 and maybe a negative number is 0. 0 up to index plus k, so that can be correct. Current index is 0, k is 1, it goes up to 0 plus 1, which is 1, which is not correct. I think it's index plus k plus 1. Okay, so for every good index in this, I'm going to do answer.append the good index. And then at the end of this loop, I'll say last index is equal to, last index is equal to index plus k. Is it plus 1 here? Or is it just index plus k? So if the current index is 0, k is 1, it's gonna go 0, 1, and I'll have last index is 1. I think it should be k plus 1. Yeah. It's not inclusive of the thing that I want to store. Okay, and then that's it. Oh, this could go out of bounds. So the max is, the min is going to be this value, but the max should be n, I think. Maximum good index is n. Okay, let's see if this is correct. Maximum index, yeah. Oh boy, oh boy, oh boy. Not correct. 1, 2, 3, 4, 5, 6. And then there's another 4, 5, 6. And then eeks. Last index, oh. This should be max, right? Maximum of index plus k plus 1 and n. I wonder. That's an if statement right there. I wonder if I should be doing some better logic there. Oh. Interesting. So it's gonna go through. What is it doing right here? So it's good index is going to be maximum last index, index minus k. 0 minus 1 is -1, which is fine. And then max index plus k plus 1. Index plus k plus 1. If this matches k. Alright, I think I need to just not figure this out in my head. Print the answer each time. Index, nums index. Right, so first one is a 2. Answers already 1 through 4 or 0 through 4 already? That should not be the case. Huh. Okay, so nums index is 0. Nums at 0 is 2 equals 2 is true for every good index in the range of. Oh my god, this should be min. No, it should be min. Max is definitely not it. Yeah, it should be minimum. Yeah, it's minimum. It can't exceed n. Right. So index plus k plus 1 is gonna be, doesn't work. So the first one goes 0, 1, 2, which is right. The next one goes 0, 1, 2 as well. Now why is that? It should be 3 at that point. So maximum last index and then x minus k. Last index at that point should be 3. And then index plus k plus 1 should be 4. I think. Low. High. Okay. 0, 3 is right. 5, 4, holy shit. Last index should be 3 at that point, I think. Index plus k plus 1 versus n. Oh my god, I'm so stupid. This should be min again. Ugh. That's really bad. How long it took me to figure that out? Not getting any better. Alright. Decent. I think I can get rid of those. I think I can probably do, yeah, I can probably do, say low is equal to this, and high is equal to this, low to high, and last index becomes the high. Okay, so that should be slightly faster. Okay. Is there another way of doing this? For every index in range n, you take if the nums at the index is equal to the key, and then minimum of index plus k plus 1 to n, the high. So what happens if you index out of bounds for the array? I wonder. Low is the maximum of last index and index minus k. So you can't start index minus k at the low end. Interesting. I'm thinking of trying different hacks of like appending to the array in order to not have it go out of bounds. If I do a index plus k plus 1 for all values of index plus k plus 1. Like if you don't have to do a minimum operation here by making the array so long that the index that you're getting from this is still in bounds in the array, you're saving like a minimum operation. It's like an if statement. So you're saving an if statement for the loop, trading off with some number of operations to concatenate to the end of the array so that it's not out of bounds. Do I want to try that? Or the other operation is the low. I don't know if low is the. How would you mess around with not having a low, like a minimum or maximum to calculate the low? Index minus k. Once you find a key, figure what the lower bound of that key is. I mean, the other thing you can do is just do 2 passes. I wonder if 2 passes is actually all that bad. 1 pass to determine where the keys are, another pass to determine what would the second pass really do. Once you have a key, what are you doing with that key? on the first pass. You're storing an array of starting indices based on the key spot, and then you're going to go through all your starting indices. It's the same deal. Like this is pretty much your starting index minus k. You're just doing it on the fly rather than doing it on the second pass. I could do a while loop. I can also maybe do a break. I could do a break if I detect that the high last index is already equal to n. The high is minimum. Yeah, I could do maybe something like if index plus k plus 1 is greater than or equal to n, then do one for loop. Float n, answer that pen, good index, and then just break here. No, not breaking here. Break here. Else do a regular one. Without breaking. And then I guess I don't have a high here, huh? But I do need to change this thing, so I do need to calculate this. Then yeah, this is just to say last index is equal to index plus k plus 1. Okay, well, this will stop it from doing a bunch of stuff at the end when it's still too far. Okay, there we go. So, for instance, if it was the second case where I'm already at this 2, or this 2, I filled it up all the way to the end, then I can detect that this thing should stop because there's no other indices. The reason I did it this way is because you kind of need to change the for loop and also change the behavior after it. So single if statement covering a single branch of the if statement covering both things, rather than like I don't think there's a way to decompose or kind of refactor this so that it can be done without like an if statement before and an if statement after the for loop. So yeah. All right. Anyways, kind of very minute details. All right. Summary. So this is fairly straightforward problem. Many ways to solve this. Easiest is probably 2-pass. Easiest. Logic is 2 passes. Easier might be two passes. One to determine where, oh well, let's ignore it. Here, for one pass solution, kept track of kind of the last valid index to append, to add, that hasn't been added. And when a key is found, key value is found, use the minimum or the maximum of last valid index and index minus k to not kind of repeat to not repeatedly, or to not have duplicates of any index in answer array. So for instance, if you have 2 here and 2 here, and your range is 2, technically that, like, the index 0 covers is in both. So if you just start from index minus k all the way to index plus k, every time you see key, then you're just going to have a bunch of duplicates. I guess another approach, probably slower, would be to have a set of answer indices, convert set to list after loop, and then sort array, sort list. This would avoid duplicates, but would be slower due to sorting, due to need to sort. Here this is just one pass, and then also note to have logic for the high index, when a high index to go through when finding a key. So don't go out of bounds past index n, and update the last valid index when a new key is found. So the last valid index becomes index plus k plus 1 once you find a new key, because that's the, here I used inclusive of the low index and exclusive of the high index. So index plus k is the high index that is included within the range, but then plus 1 is exclusive. You want to do exclusive for one, inclusive for the other one, because that's how I did it, because that's how I set up the for loops: inclusive of the low, exclusive of the high. Alright, anyways, time complexity, this is going to be O of n, since there's one pass for the outer loop index, and good index, the inner loop good index is strictly increasing. So at most n operations. So even though there's an outer and an, like these inner for loops, the good index never actually repeats on any index. So it's strictly increasing, so it goes through at most n indices that are good. And then space complexity, this is going to be O